Welcome everyone for another series in CPD in 43. Today is our April segment, a technical drawing standards from Dan Rossiter from the BSI, who is also VP Technical for CIAT. As usual, if you do have any questions, please do field them into the chat box and we will go through those in the Q&A segment which follows the talk. Hopefully you're all ready for a lovely technical update. So without further ado, I will hand it straight over to Dan. I will then disappear into the background, but I will be here. So please do let me know if you need me, Dan, and I'll be back in the Q&A session.
Perfect. Thank you, Usma, and good afternoon, everyone. Let me just load up my slides. So hopefully you are in for a treat, as technical drawing standards are one of my favorite subjects. And we'll go into a very deep dive into some of the technical standards that can support you in creating consistent standards for you and your organization. A tiny bit about me first. As Usman said, I work full-time for British Standards. So I'm one of our built environment sector leads. Roughly speaking, BSI is split into a number of different parts. There's training and certification, regulatory services, kind of consulting. I sit in our knowledge side, which is part of the national standards body. So I don't deal with any of our certification schemes or training courses. I just deal with our national standards. And a big part of what I try to do is kind of future gaze, speak to large organizations, governments, industry bodies to understand where standards and our standards like services can help support. So in doing so, I get involved in lots of different areas. Part of that is why I went and became VP Technical for CIAT, is because I kind of deep dive into a number of those sort of areas, in particular around digital and modern methods of construction. In relation to digital, many of you are probably doing some form of building information modeling or BIM. I look after, alongside Anne Kemp with NEMA, the UK BIM framework, which is the website that covers the standards, guidance and tools to support BIM. And I've either written or co-written some bunch of stuff, mainly around either the golden thread or how to do some BIM bits and pieces. But for today, as I mentioned, we're going to focus on technical drawing standards. Now, I thought I'd start by talking about the context of why this might be valuable. And one of the things I pulled out, and it's an old favorite of mine, is this report. So you'll be able to get a copy of the slides afterwards. I'll send the PDF over to Usman and the team. We can probably get that shared out somehow. You can see a hyperlink at the bottom. That hyperlink goes to the GIRI research report. So GIRI are the Get It Right initiative. They did a fascinating piece of research around the root cause of failure on construction projects. They effectively went out and surveyed a lot of construction professionals to find projects where things went wrong, and then worked with them to work out why those things went wrong, and then tabulated this radar diagram showing some of those various bits and pieces. The ones I'll highlight for today go in sort of anti-clockwise. You've got poorly communicated design information. Often when information has been shared, it's shared in a way that isn't consistent, which obviously causes errors, whether it's you see 3 windows on the plan, 4 windows on the elevation, and those sorts of things. It can make it quite difficult to understand, or even there can be kind of fuzzy details or lazy language used, which makes it difficult to use. Sometimes that information can just be incorrect, which obviously causes issues. Interestingly, down the bottom, this idea of ineffective communication between team members. The original idea behind BIM and those sorts of things was actually to see whether we could use computers to improve communication. What it seems to be now is that people are focusing on the 3D model side of it, and they might be talking to each other less and less. There's no reason why you can't pick up a phone in a digital world to speak to teammates, colleagues, other people on the project team. And even then on the other side of it, you have things like information overload, where there's actually too much information being shown or provided, which either then provides noise or creates the opportunity for inconsistencies. And having good, standardized, consistent drawings are one way of achieving some of these. So the way this presentation works is effectively a narrative. So we're slowly going to build up a standardized technical drawing going through the various bits and pieces. So the first thing we need is a piece of paper. Most of you will already be familiar with the A series. I'm not going to spend too much time on this slide at all, but the point is it's standardized. There's an ISO 216 that tells you about the A series and their standard trim sizes. In that, you get some interesting facts. The one being that A0 has got an area of exactly 1 meter squared. And then the way it worked is that the relationship between the length and the height of the page is 1 to the square root of 2, which is roughly 1 to 1.41, which means then every time you half it, it goes down a size. So effectively, by halving, you move down from A0 through the rest of the A's. And you'll notice that that same ratio is used in a number of places. It's used in line weights and it's used in drawing pens. Because if you look at your drawing pen sizes, it'll go 0.18, 0.25, 0.35, 0.5, and it has that same relationship. So by going down a drawing, you effectively go down a font size or go down a line weight, and it remains perfectly consistent. So using mathematics in that way makes it very clever so that, you know, if you wanted to take a drawing from A1 down to A3, going down 2 sizes of line weight, going down 2 font sizes, actually gives you a proportionate drawing, which is a kind of a fascinating thing to have come out of some of this. So we'll start off with a nice piece of paper there. I've gone for A3 just to pick one so it's sort of slightly viewable from that sort of point of view, but just know we've got a piece of paper to start with. From that piece of paper, we probably need a few extra things. Let's start with a drawing border. You look at something like ISO 5457, it tells you all about the layout of technical drawings, including things like drawing borders and some extra bits. It tells you your drawing border should start 20 mil off the left and then 10 mil around the sides. Nice and straightforward. It tells you that you should use continuous lines that are 0.7 millimeters in length. So that's cool. So we know the line thickness that we want to use. And then it adds some extra little bits in there as well. The first are centering marks. The idea being that there are some slightly kind of longer lines that protrude out of the drawing border. And these are there to help with aligning the drawing. If you're using a light box or you're bringing something back from microfiche and you're trying to scan and pull it together, having these centering marks helps align the drawings together to make sure that things fit, which is quite a useful tool. It also wants in the drawing border to separate the border itself into fields. Now, it might seem a bit OTT at A3, but as you get to larger and larger drawings, there's ability to be able to look at a drawing and pick out quadrants and sections of it. It means that actually you could be on the phone to someone and say, you know, I've got an issue with this detail. It's in A7 of the drawing, and then you can look across and actually find that area, and it's easier then to communicate about what you're showing. And then the idea then is that it standardizes the way that you have the letters and numbers on either side of it. And it also talks about the need to have trimming marks. And these effectively show the edge of the trimmed bit of paper itself. Now, you might think in a digital world, these sort of things aren't really needed. But when I was in practice, one of the things that would happen all the time is someone would print something to PDF and it wouldn't actually go to the full extent of the paper. It actually still have some of the edging on it, which actually then meant if any form of scaling or measuring was taken off that drawing, it would all wrong. So the trimming marks are actually really useful to make sure that what you're seeing is at the 100% intended scale that it's being shown at. So in building some of those bits together, you also need to pick a font, because if we're writing letters and numbers on something, we can start to know what we need to use. And one of the fascinating things about fonts that we use in drawings is that these days there are a lot more information that needs to be put on there that can be quite ambiguous. Things like email addresses, serial numbers, UUIDs, URLs, because they're being put in there, we need to be absolutely sure which letters are which isn't very easy in some popular fonts. So we're going to have a quick little quiz. So type in the chat if you're brave enough to have a go. How many L's do you think are in this string of text that you can see on the slide? It's used in Arial. Many companies use Arial as their standard font. So I wonder if anyone can have a guess at how many L's are in there. Right, we have someone being brave, thank you. I can see we got some 3s, some 4s, some 5s and 2s. And so the point is, you're all saying something different. So if this was the product ID needed to order something, then the chances are you could be accidentally ordering the wrong product. So, okay, Arial isn't particularly helpful. What if we use something like Calibri? How many L's do you think you can see now? You'll notice, interestingly, that with Calibri, there's a slight height difference, that you can see that some of them are shorter and some of them are a little longer. But again, like, I actually can't tell which one is which. Now we can move on to what is probably the most professional font of all, Comic Sans. How many L's are in there now? There we go. So we're now starting to see consistency. Now that we're using Comic Sans, everyone is agreeing how many L's there are. So what we have is a unambiguous typeset. Yeah, that's all right. This might be one of the last questions I ask, AJ. So you won't need to think you're in Specsavers for too much longer. Now, obviously, I'm not suggesting that you create all your technical drawings using Comic Sans. That would be ridiculous. The point is that the font that you use can affect the clarity of the information that you're sharing. And you'll notice that with many of the pieces of software that you can get for CAD, it actually comes with a standardized font. It's called something like ISO or ISO EUR, those sorts of things. And that's actually written following the rules and requirements in ISO 3098. And in that, it's similarly has that consistency where you can see here, for example, those L's have got a small little tail on them, so you can distinguish them from the eyes. And this sort of thing is quite important. You think if you're writing an awful lot of specification information or your notes and annotations. When I used to do heritage drawings, we actually put a lot of the cleaning and prep work stuff on the drawing sheets themselves. And in which case, using a good, sensible font can mean that you're getting clear information across in your drawing. Those standards as well also give you some standard sizes. You can see here a few of them listed there, 1.8, 2.5, 3.5, etc. And you'll notice that they are effectively 10 times as big as the line weights. So there's a relationship between the standardized line weights and the standardized font sizes. So it can operate like I talked about before if you wanted to scale your drawings down or to scale them up. So now that we know we need some trimming marks, the centering marks are the bits and pieces, we can build the next part of our drawing. So using these additional bits and pieces, you can see those there. So the trimming marks are in the corners. Things are just in red now, as you can see the new bits that we've added. So obviously then if you hit print to PDF and you can see how tight you've actually gone to the trimmed paper space or not. You can now see the lettering inside the drawing border, so we can do that kind of quadrant aspect. So if I asked you to look for something in F7, you'd know it's down the bottom towards the right hand side to aid with communication with someone. And you can see halfway across each one, you've got that slightly longer line, which is the centering marks, to help with trying to align stuff, whether it's been in storage, it's been saved on microfiche, or scanned in to start to align and set things back up together. So we're starting to build up a fairly kind of clunky frame in that sort of way. And one of the criticisms some people tell me when they look at these things, they go, yeah, Dan, this looks very ugly. And I'll say, yeah, it probably does look ugly, but it has several advantages in that way of it allows you to clearly talk about your drawing or the content of the bits and pieces, which is ultimately what we're trying to do as technologists, is convey good design information. And it doesn't necessarily need to be pretty to be efficient. Now, we have a border, we could do with a title block. If we want to talk about title blocks, we should go to somewhere like ISO 7200. That one is specifically about drawing borders, title blocks and document headers. So you can use this for specifications as well as drawings. What it has is a series of mandatory and optional fields that you might want to use. You can see the first column there talks about the mandatory ones, legal owner being kind of you as the producer of it, some form of unique reference for it, date it was issued, things like what it's called, who signed it off, those sorts of things. And there are other optional ones. I've just put a few on there that I think are quite useful to have, but you can go through the list and pick out the ones that you feel are appropriate. It also tells you your title block shouldn't be wider than 180 millimeters, so it can fit onto an A4 sheet. And if you look at other standards like ISO 9431, which we'll talk about later, which is on guidance for text on drawings, it tells you it should be between 100 and 170 mil, so it doesn't take up the whole sheet in effect. And the idea is that same title block is used on all of your drawings. So whether it's an A1 or an A3, that same sized title block is consistent and provided there for relevance. So it's easier then to reference, it's more consistent, it helps provide that clarity in there at the same time. If you need further guidance on some of these things, you can see that things like name, status, and revision can come from things like ISO 19650, the BIM standards. And while it's not listed in here, cheekily, if you look at ISO 5455, which is the one on drawing scales, it tells you that scale should be in the title block as well, which is an additional extra one on top. So throw in all that together, you might end up with a title block that looks something like this. I've obviously simplified it. I haven't put the titles for anything on there, but you can see that the titles at the top, the legal owner underneath it, the exact drawing sort of subtype, sort of project titles at the top, and then the drawing title under there. The type of drawing has been shown. It's some sort of general arrangement. We've got the purpose of it, so it's going out for planning, and then you can see the drawing ID. It's status and revision in that kind of bolded one at the bottom, and then down the bottom you've got things like date of issue, the scale, who drew it, who signed it off, and who ultimately approved it within the organization as part of that title block. So you can arrange it in any way that you see fit. They can also be long as opposed to being tall, so it does provide guidance, and that standard even gives you some examples within it showing different layouts and different versions that conform to the standard, which is quite useful. So sitting that in there on an A3 drawing, it takes about this much room. As you can see, it's sat there nice there in the bottom right corner. So obviously when you fold the drawing up and stuff, you can see it on the bit of paper that appears at the front. So our title block, drawing border, drawing are all coming together quite nicely there as we build a few things together. What we do need now is some space for us to be able to write some useful supporting text around. And that's where that ISO 9431 comes into play. So some sort of space for text is quite useful because there's lots of text we tend to put on drawings, not just text relating to the dimensions and the annotations, but maybe some context information and some other bits as well. And that's what this standard goes into. It tells you that there should be a space there for all necessary information to help understand the drawing. Normally it gets put on the right-hand edge. And typically it suggests that you make it as thick as your title block. So you just end up with a nice vertical line that separates the title block with all the supported text. And it suggests the sort of things you might put in there. It has explanations, whether you want to talk about whether there's certain quirks in there. You might put something like, unless otherwise indicated, all measurements are in millimeters, or if you happen to work for an international client, you might actually note there that the units are in feet and inches. Instructions could be involved with what documents have to be read alongside it. You could be saying that this needs to be read in conjunction with the specification or other bits and pieces. References might point to other drawings that need to be read alongside it. So if you have a drawing with sections or details, you actually could reference back out to where the actual citations are, so people can cross-reference between the drawings. You might want to stick in some sort of location figure if you're dealing with a zoomed in portion of a large and complex site, and you might even want to include some sort of revision table or something in there as well. So playing with that, I've chucked something similar up on my drawing here. So you can see that nice kind of vertical line there. I put a couple of notes in just quickly as an example. You'll see under my explanation, I've said dimensions are in millimeter, and it should be read with the symbol standard. So you could understand all the symbols that appear on the drawing. And then some instructions on there are my attempt at trying to write do not scale, but without using the words do not scale. So when you submit the drawings to some planning authorities, they don't complain. So in that way, it turns around and sort of talks about this idea that responsibility is not accepted for values obtained. So I see the note there about whether the text is a bit big. The text might be too big on PowerPoint here because I've manually drawn some stuff in. But in terms of the spacing, this is what it would look like on an A3 drawing. Obviously, if you're using A1, it would probably only be half the size on the right-hand side. It's more because I didn't want to sort of, the text would be too small along all the edges and stuff. So experiment it with it in the office, but I take the point that almost a third of the A3 drawings have been taken up by some of these bits and pieces. And then obviously I have my references because I've just mocked this up in that sort of way. Symbols. Symbols are an awfully important thing to look at as well, because they convey a lot of untold information. So what I've got is I've gone onto the Flat Icon website. I've just found some example north points. And north points are a great example of something to talk about. I've seen some of the most incredible north points from different practices. Some of them look very nautical, as if they're on some sort of treasure map. Some of them incredibly minimalistic. And they all have one single job, which is to point to where north is. So you can find that some of these, as you can see on the screen, it's a lot easier than others. You know, that top left one, it seems quite obvious where north is. As you get to say about the middle, you get just 8 pointing stars where it's very difficult to tell where north is. And you might think it's silly, but something as simple as this can affect the way that projects run. What I found occasionally, I look for silly news stories on the internet about construction. This was one of my favorites. Back in 2021, a developer built a bunch of houses facing the wrong way, and they were told they had to then rebuild them. So if people can sit there and build houses facing in the wrong direction, you know, giving them an unambiguous north point is certainly not going to help. Which shows you just how expensive this sort of mistake can be and why it's very critical that our drawings and specifications are as clear as possible. If you look at something like BS 8541, it gives you some standard symbols and gives you this lovely north point in there as well. And again, go back to point of, is this a fairly ugly north point? Yes, but can you tell which way is north? And the answer is also yes. So it's just about making sure that what we provide is as clear as it possibly can be. So chuck the north point on there. Now we're starting to get there. All we're starting to need now to complete our drawing is a bit of content. So where can we go to find some support in creating the bits and pieces that sit actually within the drawing itself? So that's where you look at something like ISO 7519. This is focused on general arrangements and assembly drawings, and actually provides lots of rules around how you might produce some of things. What it does is it talks about different hierarchy of drawing types. Most of these will be familiar to you all. It talks about site plans and actually gives some recommendations about how you build up a site plan, talking about this idea that, you know, the buildings should just be shown as sort of basic footprints. It's just a thicker line type to show the footprint of those buildings. You want to show the extent of site boundaries in that sort of way, and provides this idea of the amount of information to show, suggesting that you only show the basic amount needed and not too much information. You then get into kind of site layouts. At that point, you're moving from a footprint to the outline of the ground level, and you start to introduce additional information like a site datum, and maybe some dimensions for the relationship between different buildings, maybe showing how far they are from each other, or some changes in orientation. You then get down to the general arrangements, and that's where it talks about the fact that these can be obviously a bunch of different things. You can have them as plans, elevations, some sections / cuts, you know, some axiometric drawings, and they'll typically include dimensions for the key elements on the drawing itself. You also then have assembly drawings where if the GAs are focused on the building, the assembly drawings are focusing on some sort of composition of components. And again, you could get planned elevation cuts of those as well that could focus on the relationship of them at that smaller scale. Then you get into sort of component drawings where you actually show the exact relationship of the different bits and pieces. These might be more appropriate to some of our kind of M&E engineering colleagues who might want to set out exactly how a component works. And then you also get detailed drawings then where you can show the connections between those components. And that's where you'd show things like fixing methods and other bits and pieces in there as well. Now, one of the interesting points it talks about is this idea of, depending on the scale or detail required, is how detailed you show things. And one of the best examples of this could be is trying to show doors on drawings. because in the advent of CAD using 3D softwares, you can get the most incredible amount of detail that you can scroll in and you can see all the little parts of the jam and all the other bits and pieces. But actually, as you zoom back out, it just becomes quite messy. And when it is printed out, it ends up being just thick black kind of lines and bits that go into some of those bits. So actually, when it gets to the intended scale of it, you may choose to show or omit different bits and things. And that's where you might change the level of representation. Because ultimately, in something like a general arrangements drawing, you may only be working at 1 to 50, and all you want to do is show there's a door over there, and you might accurately show the structural opening size, but our actual door inside is quite symbolic. It's just that almost line up the quarter of an arc to show that there's a door and it swings that way, but the detail isn't necessarily needed to be there. But as you get down to the detail drawing, that's where you start to actually show the frame and all the fixings and bits and pieces that connect into it to provide that level of detail. It's not needed on the general arrangements. And just because we can show something, and it's easy to do so because of library objects you can download from MBS or whomever, doesn't mean that you should. And it's about trying to create that clarity and ease of use. So ultimately, we can start then to populate the drawing with some of that content. And using the standards that we've started talking about is how you effectively get there. So you can see there a bunch of the standards being used and being talked about on the right-hand side to come up with this sort of layout and drawing that you can see on the screen. Now, one thing that no doubt some of you are thinking about is, gosh, Dan, that's an awful lot of standards you're trying to expect me to buy just to create myself a drawing template. And I'll agree with you, it's not a lot, which is why I wanted to draw attention to a couple of things. The first is that the best standard that we have ever published from BSI, in my opinion, is BS 8888. The screenshot of it at the bottom there, Technical Product Documentation and Specification. It's a 300-page standard, and it's basically the Bible that sits in almost every engineer's office, because it has small excerpts from almost all those standards I talked about and even more. So if you wanted to look at standard drawing scales, line weights, the font requirements, drawing border stuff, different axiometric views or isometric, all the other bits and pieces, there are small parts that are the basic, what you might use 80% of the time, all in that one single British standard. And then it has useful citations then to point to where it's come from should you need more detail. It's domain agnostic, and by that what I mean is it's not specific to construction, so it doesn't have in it things like 8541 part 2, which is construction symbols, and it doesn't have 7519 because that's more kind of construction drawings when it talks about the general arrangement and those sorts of things. But otherwise almost everything I've talked about is in that one standard. But I don't even really want you to do that, because those of you who are aware of it, we as CIAT have worked with us as British Standards, and we have a kind of subscription model available to small businesses. So effectively, if you're a chartered practice and you qualify as a small business, there's actually a very competitive subscription model where you can view all the British standards for a kind of very competitive price. I think there's about 30 practices who are already involved in this, as we've been promoting it for the last couple of months, and feedback from it has been very positive. So if you're not aware of it or you are interested in it, Steve, I don't know the question about affiliates, but if you message Steve Fox, we can answer that question, and the team have helpfully put Steve's email in the chat, so we can test that in that sort of way. So in terms of the way that comes together, well, Steve's even in the chat, so we can answer that directly. Yeah, how clever is that? So please fill in the form and have a look at that. Usman.
That's absolutely great. Thank you so much for that. Obviously, one thing to highlight is we've been very specific and highlighting standards based on drawing format. Naturally, as everyone should be aware, the British standards BSI are wide-ranging and cover a range of matters and are mentioned, for example, throughout the approved documents, and can be then referred to as and when necessary in further detail for specific areas. But obviously, as we corral everyone into a 30-minute presentation, it'd be very difficult to go through everything if anyone has any questions, please do pop them in the chat box, and please do obviously reach out to Steve. Steve, if you could just make clear, I can't remember exactly how much the membership was off the top of my head, but I don't want to incorrectly say a number. So if you could just pop that in the chat box so everyone can have it there. Thank you so much. So that question hopefully should be answered. It's for chartered practices, and the criteria is listed below or in the chat box. Sorry, Dan. So question-wise, let's start it off. Obviously, there's the British standards, but also there's the PAS. So it'd be interesting to hear a little bit about that, which we didn't cover at all when we were just focusing on this area, and also have a few other questions as well that I can bring in whilst we're waiting for anyone.
Yeah, sure. So I'll start by saying that regardless of what we typically publish, with the exception of a couple of standards, I'll point out first, they're all voluntary. So BSI standards are voluntary packages of convenience, and what happens is they are given status by people citing them in specifications or cite them in other places. And that doesn't matter what type of standard they are. Some exceptions are things like the IAT wiring regs, as well as the Eurocodes, which are mandatory on public sector money pay projects and those sort of things. But typically, things like the standards I've shown you today, no one has to follow them, unless obviously when you're employed, someone says in your spec, you're required to follow these sorts of standards. Now, in terms of the types of standards, ISO are the international standards that come from the International Organization for Standardization. You get EN standards, which come from CEN. And then you get R's, which typically are British standards. Now, we also publish things called published documents, which are kind of standards-like, but not quite standards on the formal side. But you also get sponsored standards, which is where PASs and flexes come in. So what happens is someone might club together and decide they really want a standard in a space, and will actually then basically fund the production of that standard. And typically it's in areas of kind of rapid involvement or where a quick response is needed. So we did some flexes, for example, around some of the COVID stuff. We've done some around neurodivergence. We've done one on, I think, menstruation and those sorts of things as well in the workplace in sort of high critical sort of areas. And then when you get to sort of more nascent stuff, we did one on, say, digital twins for the built environment. In that kind of new place, we wanted to be able to do something that we could iterate on and do things quite quickly. So you typically find that where it's new and shiny, we'll do things like passes and flexes because the landscape's changing, it's evolving, and we need something that we can tweak and change more often. And then where it's established, they typically are in the BSEN and ISO side, because there isn't as much innovation happening in those spaces, and then we don't check those or revise those as often. So a flex could be revised multiple times in a year. A PAS is normally revised once every 2 years. Something like the standards I'm showing you today typically don't change once every 5 years, and even then they might look at them after 5 years and go, you know what, it's perfectly good. We'll wait another 5 years before we decide if we want to change it or not.
Great. Just to summarize then, PAS, Flex, EN, and BS, just the four that you went over, is that right?
ISO, EN, BS are the formal ones.
Yeah.
And then PAS and Flex are those kind of sponsored ones.
Perfect. Thank you for that. So we had a couple of questions in. So one from Sam, an inconsistency which I find quite often is difference with the line color and type representing standards. Standing building materials, i.e. breather membrane, VCL, etc. Is there a standard for this, or is it defined by each individual practice?
So good question. Some of that is covered in BS 8541 Part 2, where it does go through some sort of standard hatching bits and pieces, as well as some of the material hatchings. But what we find is that as a national standards body, we only run by consensus. So what happens is that if everyone can agree on it, then it can get standardized. But if someone sits there and says, well, no, actually, we do it this way, no, we do it that way, then it doesn't get included in the standard. And we've actually found that with the water utility companies, we've tried to standardize their symbols once or twice because people have called for it. And then we find out that the main big ones all disagree on what those symbols should be. So it doesn't go any further. So hopefully you'll be able to see some of it in BS 8541 Part 2, but it might not have all the ones that you want to have in there. Otherwise, that's where you just have the default then to the normal practice of having a key or something to explain it, as opposed to saying, go look at this standard that tells you what those things mean.
Great, thank you for that. Another one which I've come across recently and be really good to highlight is, as you mentioned, is varying levels of detail come up with dependent on the output that you're looking at doing. One which is really interesting, which is coming to the BIM sphere, is I've heard on a number of occasions and has been referred to in slightly different ways, the level of detail, LOD 100, 200, 300, 350, and so on. It'd be interesting to sort of hear a little bit more about that. And also as well, I know from memory, there's a number of different ways it's referred to. So it's not just LOD, there's also another one. But yeah, if you could please answer that, that'd be amazing.
That's fine. And then answer Gemma's question in the chat. I don't know a standard for M&E symbols. I'm afraid I think it suffers that same water problem, where it's very hard to agree what they are. Just to kind of knock that one out. But if I do find one afterwards, I will let the team know so we can forward it through. I'll double check. But in terms of the level of detail, the difficulty is, yeah, there are a few different conventions for it. And what happened was the American Institute of Architects, the AIA, did, through their BIM forum, created the original kind of LOD idea of this 100, 150, 200. And the reality is it doesn't work because it's too simple in that sort of way. In that, when you have a drawing, there might be different elements of the things in there that you would want at different levels of detail. And it's very hard to do the subtlety of, if you wanted to know whether those doors are lockable or not, as an example of a piece of information, you might need a much higher level of detail to start getting to the properties of whether it's lockable or not. So it's very hard to bespoke as well in that sort of way. So what's the works happened in Europe and internationally to create what's known as level of information need. And there is a standard for it, ISO 7817. And basically it talks about the idea of basically writing out almost more like a specification, how detailed you want the geometry, the documentation and the properties and stuff that go against it to be. So it's almost creating a bespoke LOD system in that way, but instead of using numbers, it's then actually just describing it and saying, for these things, I need it to be this detailed and I want to know this about them. And they've been developing that up, and they're in doing so developing up a data schema and stuff for it, and they're talking nicely to the Building Smart people that do some of the process modeling. So in theory, it's all gonna sort of tie together, but I think it's from speaking to a lot of people who've worked on some very large projects, like a friend of mine on HS2 and stuff, it's not really usable. The 100, 200, 300, or it's written and it becomes meaningless because when someone says, well, what does that actually mean? You'll then either have to look at some default versions, and then when you want to clarify, well, that doesn't actually meet your project requirements, it all falls apart very quickly. So the 7817 method is better, but it takes more effort to do.
Makes sense, yeah. And ultimately, I guess with anything is the level of understanding from one and the other. If there's a misinterpretation from one person to the other, ultimately it's not going to help either party, because one is thinking that they're being completely clear and the other is completely misunderstanding the position that's been taken. So it's really interesting to hear about how standards are even continuing to develop and meander and really sort of take hold in different areas. And as mentioned, it's good to do further reading on all of relevant set areas of the PAS, Flex, ISO, EN, and BS. But obviously, as mentioned, CIAT are in a very unique position, having created a offer with BSI to have small businesses who are chartered to have a membership and access all of the standards for a relatively nominal fee on an annual basis. So it's something worth considering. Obviously, if you are in a lucky position to be working for someone slightly larger, that's something which you can discuss directly with BSI. There's obviously discussions, there's obviously established membership models for that. Most businesses probably of that, so those sizes will probably have these memberships already, but Steve could obviously discuss that with you if that's something that you've yet to introduce to your practice. So before we bring it to a wrap, Dan, did you want to add in any final points before I highlight the remaining talks for the year?
I'll just quickly say, if I go back on my slide, I did have a summary point on a slide. Here we are. I think my points to walk away with are the sector suffers from too much information, poor communication, and poor coordination. These standards, as I mentioned, exist as voluntary packages of convenience, and they may help you create internationally consistent technical drawings that might help with limiting the information to just what's relevant, helping you communicate effectively and clearly, and ultimately help with good coordination of design information. And I'll probably leave that there. Thank you.
Great, thank you for that, Dan. I think that's really useful. Ultimately, that's our speciality is displaying drawn information and communicating a message through drawings and also written words. So just to highlight, thank you everyone for attending today. That's much appreciated. Really interesting conversation and questions to wrap it up as well. As you'll probably see on the screen, we're partway through the year. We've just completed our April talk, and as you'll see, we've got a full schedule of events for the remainder of the year. So we have our May event, which is a psychological health for ATs, which is coming from the ABS. Should be really good during Mental Health Week as well. So we have that. Then we have our June event, which is how ATs can shape health and well-being, from Anne Banner from Healthy Buildings. July event is a special, which is celebrating 60 years in 43 minutes from our very own Adam Endicott. August is reducing embodied carbon with a structural engineer, Will Arnold from iStruct-E, who's very outspoken in regards to embodied energy in engineering. So it'd be really interesting. He also is involved with the proposed Part Z standard. September event is limited in thermal bridging by design from Matthew Brook Pete, who's also a fellow of the Institute. Then we have our October, which is planning and regeneration update for this year, which is from Savills. And November is wildlife friendly lighting design from Jennifer Neal. And to wrap up the year is why specify natural slate and firelight from Simon Johnstone from SSQ Riverstone. We have already started booking into 2026. Please do let us know if there's anything specific you'd like us to highlight. Obviously, we have essential things that we're trying to sort of put in, but also as well, we'd want to make sure that we're staying on the pulse of the membership, making sure that we're highlighting specific events for you to engage with, and make sure that we're addressing emerging needs. So please do let us know. If you to contact us directly or contact central office, it's not a problem, and that can be ported accordingly. Have a great rest of the day. Thank you again for attending, and I look forward to seeing you at next month's event.